Pak Leo udah masuk lagi.
Halo, Pak.
Okay, sorry about that. That was a quick overview of roller chain, kind of their properties. Just give you a general understanding what's going on. This other video will go through in more detail. But it's 8 minutes long. It's 10 minutes, but just watch until the 8-minute mark. Okay, only until the 8-minute mark, and go back to Zoom. And come back to Zoom once you're at the 8-minute mark. Okay, is everybody back?
Iya, Pak.
From the video?
Udah, Pak.
Okay.
Menit lagi, Pak.
Okay.
Menit lagi, Pak.
Okay, I'll give you 1 minute. Raise your hand if you're here for the attendance. Okay, let's resume the lecture. Again, raise your hand if you're here. Okay, so roller chain, you see it in your bicycle, and quite versatile. I mean, remember the this chart? Kalian lihat full screen-nya nggak?
Iya, Pak.
Enggak, Pak. Saya nggak lihat full screen, Pak.
Oh, full screen. Kalau full screen PowerPoint-nya belum, Pak.
Sekarang udah?
Udah, Pak.
Okay.
Udah.
So remember this chart about gears, belt, and chain. The big advantage of chain is when you want high power transmission capacity, but your center to center distance needs to be long. You don't want, for whatever reason, okay, you don't want the motor to be close to what you're driving. So you have a long center distance, but you have higher power capacity compared to belt. So a lot of power transmission using chain are pretty heavy duty. This is how chains are constructed. I don't have that bushing disassembly. Hold on. Ada yang pernah bongkar chain nggak?
Pernah, Pak.
You actually have 2 bushings on it.
Iya, Pak. Setiap mata ada satu, jadi ya 2, Pak. 2 bushing setiap pasang.
Begitu dibongkar langsung brodol, Pak.
Yeah. Okay. So you see, if you disassemble a roller chain, you have the pin, that's the inside most, okay? Now this pair, the link, so one link is like this. Okay, this is A, this is B, okay? So you have an alternate between A and B. A, B, right? A is connected to this one, A prime, okay? So A with A prime will be assembled. Now, you see that B has a hole, but then over that, there is an additional bushing, this roller. Okay, so you actually have a pin, a bushing, and a roller on top of it. Now, what is important to be lubricated is in between these surfaces. So between this and the inside, and between this
roller
and the inside.
bushing roller.
The lubrication has to go in between those, not on the outside. Okay, so the outside of this roller is actually not important. So when you put some oil on your bicycle chain, you gotta put in the right viscosity. Kekentalannya itu harus tepat supaya dia masuk in between these assemblies. Ngerti ya?
Iya, Pak.
So it has to go into these gaps and into the inside. Makanya beberapa heavy duty applications chainnya itu direndam lewat lubrication, lewat oil bath. So there is an oil bath. It is immersed in it to make sure that the oil actually goes in between those. Otherwise, there is no use. Di luarnya kelihatan berminyak, tapi di dalamnya nggak masuk. So this is how they're assembled. There is the pitch. You saw those videos. Okay, you can have multiple strand. Now this is a sprocket. The sprocket is not a spur gear. Okay, it's different. It's not an involute. The shape of these teeth is different between a gear and a chain sprocket. Many chain sprocket are using keyways because many of the application is quite heavy duty. Keyway is a way to couple heavy duty movements, torques. Advantages, yes, a finite but pretty much very long life. I don't think it's maintenance, it's high maintenance at all, other than the lubrication actually. Long center distance, high transmission efficiency, not bad. Belts are lower, chains are higher. You can go up to hundreds of horsepower on this. High temperature, obviously, is made out of metal, so you can survive high temperature environment, like say in stamping or forging, die casting. Belts are not appropriate. Maintenance on lubrication is critical. Some noise, rattling noise, and there is some variation on the speed ratio, as we'll talk about it. Okay, you got single strand, you got double strand, you got triple strand. If you need more capacity, we'll do calculations on this next week. Chain can fail due to several ways. Now, there is a low cycle failure, and then a medium cycle failure, and then a high long-term failure. Okay, here when you have failure in the earlier life of the chain, that's really because of breaking load. It goes like zone A, right? Overload, and then sometimes you fail by fatigue in the medium cycles of failure, and then for the high lifetime failure is really due to wear, and you cannot really avoid that. And over time, the chain will actually lengthen. Karena kan the bushing got worn out, right? Jadi kalau tadinya ini pinnya and then ini bushingnya. If you imagine the pin getting smaller, the bushing, I'm exaggerating of course, the bushing is like this, then the center to center pitch actually increases and the chain, overall chain actually lengthen, nanti dia mulai ngedoyot gitu kan ya, because it lengthens.
Oh, berarti karena abrasif gitu Pak ya. Jadi karena
Ya.
gesekan dia berkurang.
Betul. Setiap kali dia go around the sprocket, I mean the pins actually rub against the bushings all the time, and the roller against the bushings also. So these inside diameters, they rub against each other and they do wear out, especially if you don't have lubrication.
Oke, Pak.
Now at the beginning, when you install a new chain, there is some bedding in. Okay, bedding in. In manufacturing, you always have surface imperfections. Okay, so if this is the outer diameter of your bushing, you know, you have these imperfections, right? The first time you assemble them, it's tight. And then just in the beginning hours, actually you lengthen the chain because ini yang surface yang geradakan ini, it's being polished, right? It's being worn out, and the first wearing out is called bedding in. And this initial wear will actually lengthen and elongate your chain a little bit because the surface imperfection goes out. So chain wear, like I explained, it ends up lengthening your pitch, increasing your pitch, and so overall it gets longer. 2% is the max you want to tolerate. Now if you do have an idler, jadi kalau arrangementnya kayak gini ya, ada idler, it kind of helps if it elongates, it'll still work, but still you need to replace it. Chain wear accelerates with higher speed, of course. More number of sprockets, misalnya, you know, you go around quite a few, gitu kan. Fewer number of teeth, okay? It's because of the load sharing. Jadi kalau number of teeth kamu sedikit, tentu aja, let's say the arc of contact is 180 ya, you share it among like 6 teeth instead of 12 if you have 24 teeth sprocket. Okay, so the number of teeth will actually spread the load and make it live longer. Okay, lack of lubrication, shorter chain length, because you have less rollers to, again, take up the wear, right? If you have a chain length that is half as long, that means each roller go through the sprocket wear twice as often, right? Get the logic? Yeah. Kalau chain kamu shorter, each individual bushing will go through the sprocket more often than a longer chain for the same RPM and the same load. This is the chordal variation that is kind of inherent with chain. It's not a big deal in most cases as long as your sprocket is big. But think about when your number of teeth is so small. An extreme example here is only 4 teeth, right? If you have 4 teeth, 1, 2, 3, 4. When the condition is like 1, 2, 3, 4, you see that the distance between the center and the chain, the radius, this is the effective radius. But when it's at the peak, this is the effective radius. So you see this change in radius will affect your speed ratio, right? But if your number of teeth on the sprocket is greater, then the difference is not that bad, right? If say your number of teeth is like 20, you see this position and this position doesn't matter that much. but with four teeth sprocket, which is not recommended at all anyway, it'll be much worse. That's why you see the chordal speed variation percentage drops immediately when you have the number of teeth like greater than 15. So make sure you have enough number of teeth. In general, you want at least 6 teeth engaged. Okay, 6 teeth engaged. Center distance should be about 30 to 50 times the chain pitch. So the 2 sprocket, okay, the center distance C should be about 30 to 50 times the pitch. Oke, jadi kalau 30 artinya kira-kira di sini ada 30 link. That kind of helps spread the load. And again, the rollers doesn't wear out as quickly. But doesn't have to be. The 60th engagement, I think, is a good idea. Okay, otherwise nanti sprocket kamu lebih cepat habisnya. Ya, jadi di sini nanti ini mulai worn out quicker because the load sharing is not uniform. Just different ways it'll wear. If you overspeed, this is when you overspeed. This is when you have overpowered. This is a leaf chain. It's a totally different purpose. It's for lifting. This is not a roller chain, but you can use it to lift something. Okay, there might be some slack on the roller chain, and this is tolerated up to a certain degree. This is the slack there. Okay, should be 2% of the span. Jadi S ini 2% dari jarak ujung ke ujung, ya.
Oh, berarti si slack itu harus ada, Pak, ya?
Pasti ada. Kalau nggak ada, if you over tighten it, it can also wear out prematurely the chain. You're putting additional load that is not intended.
Oke, Pak.
Alignment is important, ya. Jadi kasih garis. Jadi ini kalau dilihat dari atas, it needs to be aligned. Usually you have one adjustability, right? One of them adjusted to take up the slack. Kalau di sepeda juga bisa mundur dikit kan ya, ujungnya.
Ada setelannya, Pak.
Ya. Or if you cannot have adjustments, you can also have a tightener. Now, when the slack side is on top, some means might be provided to adjust slack side tension. Jadi kalau slack side-nya di bawah, itu not that big of a deal. Tapi kalau slack side-nya di atas, misalnya ya, yang ini muter clockwise, oke? Yang bawah, yang bawah tegang, yang atas yang kendor. Nah ini harus ada tightener. Kalau nggak dia bisa, due to gravity, dia bisa keep hitting the sprocket and kind of wears it out prematurely too. Lebih bagus kalau ada idlernya, idler sprocket. Sometimes they call this idler, ya. Idler sprocket. Because it's idle, it's not carrying any torque. It's just there to push it down and it rolls on itself. Just like a belt tightener.
Semacam tensioner gitu, Pak, ya?
Ya, tensioner, betul. This is good. Okay. You can put tightener, especially if it's on the top. Ini okay. Yeah, this is good. This is the best arrangement. This is not as good, okay? This is not as desirable. Kenapa? Karena chain-nya ini kan cenderung bisa jatuh ya, dia ngondoi gitu kan. Okay, it's kind of the slack tends to kind of open up di sini. Jadi you have less engagement on the bottom. Tapi di sini the gravity ya, kalau yang kecil di atas, yang gede di bawah, the gravity will kind of bikin chain-nya malah semakin duduk. Ya. So kalau ada slack di sini dia akan semakin duduk di sprocket besar. Tapi kalau sprocket kecil yang di bawah, gravity-nya bakal memisahkan rantainya dari sprocketnya, ya kan? So this is better. This is not desirable, but if you have to, you can put chain tightener there.
Cuman Pak, untuk kayak timing camshaft motor, sepengalaman saya malah lihatnya gear yang gede di atas, Pak.
Iya, karena sometimes mau nggak mau mesti begitu kan?
Iya sih Pak.
Nah, kalau mau nggak mau begitu biasanya ada tightener. Better ada tightener.
Sih, Pak. Iya ada.
Ya. This is just some different arrangement with variable positions. Kalau jauh ya, kalau abnormally long, jadi let's say dari sini kamu perlu transmit power ke ujung conveyor or whatever, you can do several reduction like 1, 2, 3, 4, 5, 6. Ya bisa begitu juga. Atau jauh aja nggak apa-apa, hajar dari ujung sampai ujung, tapi di support sama idler. Oke, atau supporting guide, dikasih chain guide. Cuman ini agak ada wear juga ya di guide-nya, nanti maintenance harus ya watch out, bisa ganti. Ya ini multi shaft, jadi dia rotate. Jadi one driving shaft can drive multiple driven shaft. Not as efficient, but that's possible. Kalau posisinya begini, nah ini a different position. Ini dilihat side view. Jadi kalau side view-nya seperti ini, artinya posisi sprocketnya horizontal ya. Jadi chain-nya bukan begini. Kalau begini kan gravity begini ya. Bayangin kalau sprocketnya itu horizontal kayak piring gitu. Ya kan? Kalau sprocketnya begini, ini chain kan maunya jatuh ya. Chain kan berat ya, nggak seperti belt. Chain itu lebih berat. Jadi dia cenderung jatuh dan dia bisa go out, exit the sprocket kan. Jadi harus dikasih guide ya. Jadi di sini support chain. Again, if you have to, right? Not ideal. Okay, lubrication. We talked about this, that the lubrication actually have to go in. Ini lihat yang hitam. So it has to go in between the pin and the bushing. And here, between the bushing and the roller. Ingat, ada 3 komponen, ada pin, bushing, and roller. They have to go in between them, not outside of them. Makanya, tergantung temperatur kalian, lubrikannya mungkin beda, ya. To make sure kekentalannya tepat gitu. Jadi kalau suhunya lebih dingin, mungkin perlu yang lebih encer. Tapi kalau suhunya lebih panas, perlu yang lebih kental, karena begitu kena panas, dia menjadi encer, kan gitu. You can do manual lubrication. You can do drip. Jadi sambil dia operating, ada dripnya. Mungkin bisa di recirculate juga. Bisa oil bath, direndam. Jadi as it goes around. Tapi ini butuh casing jadinya ya. Kalau misalnya seperti ini, you need a sealed casing. Jadi it goes through the oil bath. Bisa pakai pump, disemprot. Tapi ya ini lebih kompleks ya. And also you're relying on the pump. If the pump fails then, and you don't know the pump fails, can be an issue. This is a catalog we will be working on from Timken. But let's push that for next session. Any question on chain? Sebenarnya kita bisa langsung Socrative chain sih, karena I've covered the main design aspect of chain.
Pak, mau
Ya.
nanya dong Pak. Kalau chain sama belt, akurasinya bagusan chain atau belt Pak? Secara itu chain ya Pak?
Chain tetap lebih akurat. Karena karena dia nggak bisa slip kan. It can wear out, but it doesn't slip. So overall, your overall speed ratio will be much more accurate than belts. Sama timing belt mungkin mirip.
Oh, tapi kalau timing belt sama chain hampir 11-12 gitu ya Pak?
Iya. Tapi capacity jauh lebih tinggi chain ya.
Oh, oke Pak, makasih Pak.
Timing belt nggak ada slack, itu enaknya. Timing belt lebih nggak ada, ini backlash. Chain karena dia ada slack, dia ada backlash sedikit. Jadi if you're doing positioning, if you're doing position sensitive devices, I would go with timing belt. Yang sulit mungkin kalau kamu position sensitive dan high load. Nah, itu rada repot. Kamu mungkin mesti pakai gear. Timing belt ada limitnya ya, dari segi strength. Tapi chain are not usually used when you have position sensitive. Pokoknya position accuracy lah. When you need position accuracy, usually don't use chain. Chain is for heavy machineries kind of applications.
Oke Pak, makasih Pak.
Oke, kita langsung kerjain Socrative-nya deh. Sekaligus kalian masih seger kan? Baru denger. Jadi masuk aja ya, room yang SGUMD. Sama. Buka Socrative. So, just getting one more thing done today. Oke, saya udah launch. Langsung aja.
Berarti langsung masuk nilai ini, Pak?
Ya, langsung. Jadi kalau yang tadi ditinggal tidur,